Hello and welcome to another edition of James and Chris Science Videos, where today we're going to be looking at germination of seeds, what seeds are made of, and the conditions that are needed for germination to take place. This is going to include an investigation that I'd like you to try, where we'll also look at some of the key variables that you can use when experimenting on germination. Let's start then. The first thing we've got to do really is look at a seed, and I'm going to take you through the very basic names. Now, as you go through and do GCSEs and A levels and beyond, the names of these change and we use slightly more scientific names. But at the stage we're at the moment, there are really 4 labels that we need to know. And we'll start with the first label, which is the seed coat, which is a tough outer layer of a seed. And this is here to protect it. So when it produces its seed, and it disperses it in some way, that seed in the inside needs a bit of protection from the elements, the heat, and to stop some animals eating it. If they're designed to be eaten, that seed coat needs to be impervious to stomach acid. So that seed coat is going to be that protective layer. Inside that seed coat, you've got a food store, which is going to be really important because plants can't eat. They make their own food using photosynthesis. And the initial stages of their life, they don't have light with which to work with. And so they need that food store already there. The last 2 labels that you need to know are the embryo shoot and the embryo root. I've just put embryo on this picture here, but the shoot being what looks like a folded up leaf and the root being below it. And those are going to form the 2 major structures of the plant as it grows. The shoot being the stem, the leaves, and all of the above ground equipment and organs. The embryo root is going to contain all the organs that go below the surface. So here's a little table. It's just useful to write down what each part does so that you can remember it. Now we've learned what a seed is, we need to look at what germination is. And this as a term is when a seed starts to develop after a period of dormancy. Now, when it's pollinated, it will start to develop and it will grow to a certain size. So it reaches a certain stage of development. Then it enters dormancy, which is it's like a plant equivalent of sleeping. It goes into hibernation. It stops growing altogether. It just stays in stasis. And it can stay like that for incredible amounts of time. 2, 3, 4 years. There's some seeds that will only germinate in deserts when it rains, and that could be 10, 15 years. So they're incredible. They just wait dormant, and that once that dormancy is finished and they suddenly go, ooh, time to grow, that's when germination has taken place. We need to know what conditions then are needed for it. And what I've put down here, I've put 6 possibilities. Not all of them are needed. So don't think there are 6 things needed for germination. That is not true. These are 6 possibilities that plants might need. We're going to look at how we can investigate and do some experiments to find out if they are in just a second. So we could need water, we could need oxygen, we could need carbon dioxide, we could need sunlight, we could need soil, and we could need temperature. And so what we're going to have to do is come up with a way of investigating if each of those are needed. So let's have a look. The first picture I've got is just a simple way that you could measure and investigate temperature. So I've got 2 test tubes here, both with moist cotton wool at the bottom, both with seeds in the bottom. And all I've done is I've put 1 test tube in a warm place and 1 test tube in a cold place. And we'll see if the seeds germinate in one or the other. That's easy. Investigating oxygen is a little bit harder. How do I stop oxygen getting to the seeds? The only way that you can really do it is to put it under water, but to make sure the water is boiled. When you boil water, all the gases inside it come out. You see, when you heat it, it starts bubbling. It's not the boiling bubbling, that's slightly different. That's bubbles of steam that form at the bottom and then force their way up. But before it boils, you'll see lots of bubbles kind of effervescing throughout the liquid, and that's all the gases that are dissolved in the liquid coming out. So if you boil it for a period of time, you put the seeds in it, and then you put a layer of oil on top, and that will stop any oxygen going into the water. That will give you a test tube with no oxygen in it. Then all you can do is you just put it onto, compare it with a test tube with. It's got dry cotton wool there. So that will then see if that has an effect. Then we could do investigating carbon dioxide. The investigating carbon dioxide, we have to use a chemical that will take away carbon dioxide, will absorb carbon dioxide. Sodium hydroxide is one. There are a few chemicals that will do that. And so if you leave that not on the seeds, because it's caustic, it'll erode the seed coat. But if I put it somewhere in the same container, then the carbon dioxide that's present will get absorbed, and so we can guarantee there's no carbon dioxide there. Investigating water is easy. We set up an experiment with water in it and one with dry elements in it. So that is really easy to do. Investigating soil, again, that's easy to do. All we do is we take one pot with soil and one pot with something else. You can use tissue paper and so on. And so that will be very easy to set up. But the one that I'm going to talk about, the one that we're going to try, is investigating light. Is light needed for germination to take place? So I'm going to just quickly take you over to my conservatory where I'll show you how to set up an experiment for this, and I will see you in a couple of minutes. Well, here we are in my conservatory where we're going to have a look at doing that experiment to see if light is needed for germination or not. Now, for this experiment, all you're going to need is 2 plates, some toilet roll, kitchen roll will be better, a bowl, some seeds of some kind, and this we've got some runner bean seeds that we grew from last year, and a little bit of water. And I'm going to show that and how that works. So, a bit of preparation. On each plate you take some tissue and create a bed on each of the plates, like so. So I'm going to put onto that plate there, we've got some tissue paper, that's going to soak up the water. We're going to put the same amount of toilet paper on this one, just like this. So I've got 2 beds for my seeds to grow. Then I'm going to take the seeds. Now, it wouldn't be fair to just do 1 seed. That wouldn't make it very reliable. We're going to need to repeat it. Now, in order to make the best result, we're actually going to put 10 seeds onto each plate. A little hint, if you've got larger seeds like these, if you soak them into water first, I'll just put a couple in for the moment. If you soak them in water first, then that will soften the seed coat, and that will increase the chance of your seed surviving. So, I'm not going to do that because it's a little bit early in the year to be using these seeds. I'm going to come back and do it a little bit later, but we're going to take 10 seeds. So 10 seeds should have been soaked. I haven't soaked them, but 2, 4, 6, 8. And another 2. So there's 10 seeds there. Onto that, we're going to put some water. And we're going to put it so it soaks the whole of the tissue paper. And then I'm going to do exactly the same to this one here. 1, 2, 3. There you go. Was that 6, 7, 8, 9, and 10. And I'm going to try and pour the same amount of water onto this plate. So far I've kept it as identical as I can. The independent variable is going to be whether it's got light or not, and we're just going to simulate that by putting a bowl over one of them and not the other. So once you've got the 10 on each, you put the bowl over, you then can leave it, and I would water it maybe once a day, maybe twice a day, but trying to keep the amount of water the same. All you then need to do is every now and again just have a little look under, see if it's germinated, and see if those have germinated, and then count how many have over that time. So there you go, simple. Brilliant. Hopefully you've set up your experiment. Hopefully you've got the seeds in place. So let's go through this investigation. Let's have a look at what we saw. Now, when talking about investigations, we like to use the word variables, and there are 3 different types of variables that you need to talk about: the independent, the dependent, and the control variables. So for the example I've given you for the seeds, I'm going to talk you through how to identify each of those variables. Now, the independent variable is the condition that we changed, and it's what we're actually investigating. So in this case, we are investigating light. We are seeing if light has an effect or not. So that's that. We then go to the dependent variable, the second type of variable we need to know about. And the dependent variable tells me how many of the seeds is germinated. This is the variable that we're going to use to measure our investigation. And in our investigation, we're going to use, oh look, there were 8 seeds germinated in that condition, no seeds germinated in that. I'm using the number of seeds that germinated as my variable to judge my experiment. We've then got control variables. These are going to be all of the variables that we're going to keep the same. So we would go back to that original list. We had those 6 variables that could affect them. We've chosen, in this case, light as our independent variable. That means all the others, that's temperature, amount of water, access to oxygen, access to carbon dioxide, soil type, all of those need to remain the same. And as long as you keep them the same, that makes it a fair test. So let's have a look at those conditions. Now, if you've tried this, if you've tried at least the sunlight, and you can see whether it has an effect or not. But I'm going to go through the factors that could be. So we'll start off with water. Yes, seeds will only germinate if in the presence of water, which is why soaking them beforehand is a good idea. Oxygen, yes, they're living organisms. They need to respire. And so oxygen is certainly needed. Without oxygen, it will not germinate. Carbon dioxide, no. Now, a lot of people are surprised by this because they say, oh, it's a plant. Plants need carbon dioxide, but they need the carbon dioxide to photosynthesize to make their own food. Seeds don't need to do this because they've got their own food store already there. So they don't need carbon dioxide initially. They do later for photosynthesis, but not for germination. Sunlight, no. Both of your plates of seeds should germinate. And the reason for that is that you tend to find seeds and you put them underground. And so, again, they don't need to make their own food. They've got their food store. And so sunlight isn't needed for the germination. It's needed later. Soil, no. Plants will germinate anywhere as long as they've got water, oxygen. So you can plant your seed pretty much anywhere. Adult plants do need some nutrients from the soil, so eventually they are going to need soil, but not initially. Germination will happen without it. And the last is temperature is, yes, they're kind of initiated and triggered by temperature, which is why if I plant a seed in the ground, it won't start growing in the middle of winter. It needs a certain temperature for it to activate. So those are our different factors. That's what we need for germination to take effect. So let's just look at a quick summary. We've looked at seeds contain 4 simple parts. We've looked at the seed coat, food store, embryo shoot, embryo root. We've looked that seeds will need 3 conditions to germinate, that is water, oxygen and warmth. We also recapped via the experiment on the different types of variables. We looked at independent, dependent and control variables and how to identify them in an investigation. Thank you very much for listening. I hope to see you again soon. Bye-bye.